Alright, welcome to the video overview for Project 1 for GPU programming. So what we're looking at is the GLSL window. I see it's divided into 4 sections for each of the shaders. So I can click on each of the 4 regions in order to maximize each shader. I can also do the same thing by pressing Q, W, A, and S. Press Z to restore back to the four-way split screen view. I can also press 1, 2, and 3 to switch between the various shader pages. Alright, so for the first shader page on the upper left, we have a night vision scope type shader, and we have a lens distortion tinted green with some boosted luminance and some little noise in there to give it kind of that grainy electronic night vision scope type effect. On the upper right we have the light bright shader. So we're taking the camera image and mapping it to about 1 of 8 light bright colors and place them in a offset color grid. So if I bring in this Clorox wipe container, get a good example of some of the color ranges here as we're picking up the greens, blues, and whites. So we really get the Clorox logo in particular. You can really see the colors in there. Brings us to the next shader on the lower right, which is the tune shading one. And again, we're actually using a similar color separation technique to do the tune shading here, as well as a similar mode for gaining skin tones, which works fairly well based on lighting. Occasionally you get some hot spots that start bleeding to the red if we get a large specular reflection. Going on to page 2, we have on the upper left we have kind of a old CRT blue hologram type effect, got flickering scan lines and a bit of grain, as well as again boosting some of the luminance so we can get a little of that kind of bright overexposed hologram look at some point. On the upper right, we're taking the camera image, putting it through again lens distortion, and then you can also see some chromatic aberration for this one, especially on edges in the image. And then for the lower right one, is actually one that takes more advantage of luminance value in the image. So what we have here is we're taking the camera image, applying it through a luminance filter, and then using a noise generator, which is documented on the website. We kind of get this kind of thermal imaging, heat vision type effect. Finally, on the third page, we have bump mapping examples. So shader here in the upper right. So what we're doing here is we're taking the camera image, reducing it to passing it through a luminance filter again, and then this time we're passing that in as a normal map. And right next to it on the upper left, we just have a procedural bump map example for comparison purposes. So you can see here, as I move the mouse cursor around, I can change the position of the light that's being shown on these two bump maps. You can see some specular highlights appearing on both maps. And in addition to that, we can press R to rotate the planes that both bump maps are on, so we get a better sense of how the bump maps are working here. And press 3 to stop the rotation. And that's it for the overview for Project 1 for GPU programming.